Okay, recording started. Let's get that up. I'll share my screen. Alexander, you joined? Why? Huh? Oh, okay. Okay, so let's see. Okay, well, looks like we're good to go. Looks like the internet is a little bit slower today, but see how that goes. So, we talked about different cements, and we said that there are different types or different forms of cements, right? We have liners, we have bases, and we have luting cements. Technically, liners are thin layer, right? They're mainly for pulp protection. They also can stimulate dentin, right, formation. Luting, that is also another thin layer. We call it a primary consistency. That is the main cement that we do glue things with, like orthobands, brackets, crown bridges. And bases are thicker layers, and they're for thermal and chemical insulation. And again, this picture shows everything. Bases, again, are not much widely used nowadays because of the uh, they're were mainly used with amalgam, right? Because amalgam is metal, and we need some insulation uh, from the thermal conductivity that it makes. And we know that we have different classification. So type 1 and type 2 and type 3. So type 1 is what? The luting. Type 2 is the temporary, and the 3 is the base. We talked about varnishes that are not cements technically, and they're mainly to reduce sensitivity, right? And also can minimize some micro leakage. And we talked about the main varnishes that we have in the market: Cobalite, that is used under amalgam fillings, and we have the Gluma, that is the newer type of varnish that is mainly used under any kind of new restorations. And then we talked about liners that are thin, and we know that we have direct and indirect pulp capping. So direct, when we have a direct pulp exposure, right, and we cover it with a liner, and indirect when we're close to the pulp but not hitting it, and we still covered it with a liner. And we talked about the different types of liners that we have, like Dical, Vitrobond, Therical, and Lamlights. And I think we stopped here, right? Okay. So some properties of luting cements. So now, after we're done with liners, we're going to talk about cements, which is the main uh, part. And we know that cements or luting cements are class, and the classification for cements is what? One, right? Exactly. So definitely strength is something that we look for uh, in our luting cements. So it is the resistance to deform or fracture under force. Let me see here. Adhesion, we have mechanical and we have chemical types of adhesion. So how the cement itself works, so it can be mechanical, interlocking like Velcro, just like mechanical. Again, it's not like the actual molecules. And we have chemicals at the molecular level where actually two atoms are kind of get together because they swap some electrons. And then we have radio opacity. And technically, we make our cements, we add materials to our cements to make them actually appear when we take x-rays. This is important for us because if our cements would not appear under, with radiology, we might think there is a cavity or there's a recurrent caries that are happening under the crowns or bridges that we have, that we glue with the cements, right? So we add actually some materials. So then when we take an x-ray, we can see the cement as radio opaque, which is technically whitish or grayish. So we can actually distinguish it from a cavity. And aesthetics, how it looks. So because sometimes we use cements under translucent material, sometimes crowns, sometimes veneers. The aesthetic of the cement as well can be a factor to play. So how it will look like, and would it be resembling the actual tooth color or not? So sometimes some cements will have some tints in them or some colors, again, because they might actually show through the fillings or the materials that we put. Solubility is another important factor. Would it dissolve in oral fluids or not? Definitely, if it does, that can lead to microleakage where bacteria can access the tooth and cause some secondary caries. So that's another feature to look at. How bad its effect on the pulp, or does it have any effect on the pulp? So sometimes some cements have some acidity, like zinc phosphate, and that are less used nowadays because of their acidity, because they can irritate the pulp. So again, this is something to look at. How viscous and how much we want of, or how much we need of the cement to be able to work. So definitely, the thinner the film, the better for us. If we can have a thinner cement that will do the job for us, that will be better because we can then prepare the tooth less and have the fitting much better on the tooth. And then how we manipulate it. Is it easy manipulated? Is it easy mix? Is it technique sensitive or not? And so on and so forth. So these are some properties that we look at in diluting cements. Okay, now we're going to talk about these. So diluting cements, we know that it's thin and viscous, and it's is it primary or secondary consistency? Primary, right? It's primary consistency. So when we talked about cements, we know that there is a primary consistency and there's a secondary consistency. And we know that diluting cements, technically this is what we talked about already, but since we're going to talk about them more specifically, this is just kind of a reminder about all of the things that we have already talked about. So it is used for restoration, as we know, crowns, bridges, can be using for orthodontic bands and brackets. Adding more powder to a luting cement can create a thicker, thicker, so that it can make a, instead of luting, it will be a base, right? It can be a base. A lot of these cements that we have, if we mix more powder to them, we can technically use them as bases. Okay, but again, bases uses are not much used nowadays because of the composite material and the new restoration material that we're using in the field that actually would not require installation of a base. Anyway, always, whenever we're talking about cements and we're mixing cements, you always, as we said, any kind of powder in dentistry, you want to fluff the powder and swirl the liquid, right? So we're not going to talk about this when we're talking about cements anymore. Anytime you have a liquid and powder, you want to always fluff it a little bit, swirl the liquid to make sure that you're getting all of the parts of the cements mixed together in a homogeneous mix where you can actually use it. Okay, bases, as we said, bases are a thicker layer, so they're secondary consistency, right? And we know that they provide thermal and chemical insulation. Again, because we're going to talk about these. There are different types of bases. There are low strength bases and high strength bases. And the high strength is about four times more stronger than the low strength bases. Okay, we're good. Moving on. So from the slides, I think from this slide on, we're going to talk about the types of cements that we have. Luting cements mainly. Some of them can be used as bases as well, but mainly cements and their chemical uh, composition and what are some of the features that they have. And these are the main cements that are out there, even if they are, again, you might see some different ones out there, but they're mainly the same components, at least, or in the same category. So, okay. So zinc, and again, we're going to mix these next week. After we're done with this, we're going to mix next week. So that will relate much more better when we're doing that. We'll start mixing cements and you'll be mixing these with hand. So hopefully this would relate once we start mixing cements. So zinc phosphate. This is the first cement that we're talking about. And these are the actual cements that we're going to mix in the lab. This is how it comes. It's an older cement that is honestly rarely used today. Uh, you might find some dentists prefer it, because they just like it or not. But again, it's you will not see it as much as the other cements. So it is a permanent cement, so it's not a temporary cement. It can be used as a base and can be used as luting. So if you mix it, if you mix more powder to it, you can use it as base, right? It is rarely used today because of, I did mention that a little bit earlier, acidity. So when we were talking about how the cements uh, can interfere with the pulp or can affect the pulp when we are choosing cement. So this is one example that we're not using much anymore today because it has some acidity and it can affect the pulp. So the composition for zinc phosphate, the powder is zinc oxide and magnesium oxide, but from the name, kind of. And then the liquid is phosphoric acid and water. So we're going to try to remember these. I'm going to ask you questions about them, but most probably like not to multiple, like in a multiple choice, for example, or true and false. So as you'll see, and I think we have a table at the end where I didn't do that here. Maybe I'll share it with you guys later. But we have a table where we have all the cements, what they are, what is the powder, what is the liquid of them, so you can compare and you can kind of see everything in one place. That will be really helpful for you. So again, from the name, it's called zinc phosphate. So the powder will be zinc, right? And the liquid will be phosphoric, right? So it's phosphoric acid and water. Did I put that in here? Let me see. And this is how we usually write it. So it's ZNP, zinc phosphate. That's how we would abbreviate it usually. Okay. So some of the disadvantages of this, it's irritants definitely because of the acidity, and it has a mechanical bond. So technically it needs some retention to actually bond to the tooth. It's not like a chemical bonding to the tooth. Remember when you're talking again about the bonding process, is it mechanical or is it chemical? Usually the chemical bonding is much stronger, and that's what we want. So some of these disadvantages of that zinc phosphate is that, again, it's irritant and it also have a mechanical bond. One of the also other issues of the zinc phosphate, as you can see, this is how you have to mix it. It is mixed on a glass slab. So Again, that is rarely done nowadays. The problem with that is it releases heat, so we call that what? An exothermic reaction, exactly. So when you mix it, it actually makes an exothermic reaction. And if we want to have enough time to work with it and for it to set correctly, we need to mix it on a cool glass slab. So we do have these glass slabs that we put in the refrigerator, and then we mix with small amounts, a little bit by a little bit, and in a wider range, as you can see, with an 8-figure motion, just so that it would not heat up on us and that the glass slab will dissipate the heat a little bit by a little bit. So again, this is really what we call a technique sensitive. You have to really get it down where you can mix it correctly without setting up on you and getting the right consistency with it. And again, that's another one of disadvantages of zinc phosphate is that it's really technique sensitive, and it requires a lot of preparation. And again, nowadays it's not used anymore, or really rarely used. So, as we said, because it's irritant, we need maybe a pulp protection. So we might do some kind of bases underneath it if we're going to use it. Most probably not. And then the examples that we have are high bond and flakes that are shown here in the beginning. This is high bond, and this is flakes that are zinc phosphate. Again, we'll mix in the lab, and then we'll have that table of all the cements together that will make a lot of more sense as we move on. Okay. Another type of cement is polycarboxylate. So the polycarboxylate, it's another permanent cement. It's also used for luting. It also used, technically any permanent cement almost always, I mean, definitely use luting, crown bridges, these kind of things. So you can almost use all of them together, same thing. So the powder for that is zinc oxide. So it is similar, right, to the powder on the zinc phosphate, correct? Same powder, but the liquid is different here. The liquid is polyacrylic acid, I'm sorry. So kind of again, from the name, poly, you have poly here. So hopefully, again, a little bit by a little bit, you guys are going to start differentiating and getting to know the different powders and liquids for each of the cements that we have. So polycarboxylate cements, and talk about all of that. Zinc oxide is the powder, and polyacrylic acid and water. Okay. So some of the properties, it's a little more lower strength, but it actually chemically bonds to the tooth. So this is something good because, again, a chemical bond is better than a mechanical bond. A little bit of acidity, so we don't have a lot of irritation. Again, it's not similar. This polycarboxylate cements are still in use in offices more than zinc phosphate. Some of them have fluoride, which is a good thing. You can usually, most of the cements nowadays come with if they're mixed by hand, they come with a mixing pad, which will be the best way to mix it on. This is Duralon. This is a again, polycarboxylate. I'm sorry. Yeah, polycarboxylate cement. Um, and it has a specific way to actually take it. It's not a scoop, something you push in and you get the powder. Anyway, we'll do that in the lab. And then one of the things that we want to notice when we're mixing it, it has the luster or the gloss on the surface when we're mixing it. If it's gone, that means we overmixed it. Some examples are Duralon and high bond polycarboxylate. Duralon are the more used ones in offices nowadays. You might see that in offices. Again, of this type of cement. Okay. Again, I know, I mean, these makes a lot of more sense when we start mixing, but getting them down at least, and then as we mix, we'll try to remember these information. So glass ionomer cements, or GIC. Glass ionomer cements are really, really important and widely used nowadays in offices in different formats and in different um, ways. And a lot of companies make, products of glass ionomer. One of the most important thing about glass ionomer, as we will see in a little bit, is that it releases fluoride actually, and that is the good thing about it. So it is another permanent cement. And as you can see, glass ionomer as a material, again, we're talking about the actual material, it can be used as luting, it can be used as a base, can be used as a liner, and it can be used as a filling. So all through, right? You can use it in a filling, you can use it in a liner, in a base, in a luting. They can use it sometimes even as a sealant. So that's a great thing about glass ionomer. Composition is aluminum fluorosilicate glass, right? Because we call glass ionomer. And then the liquid is polyacrylic acid and water. So what was the liquid? Where did we see this liquid before? Right? Polycarboxylate, right? So the same liquid here as the polycarboxylate, but the powder is different. You have fluorosilicate glass. And again, when you see glass there, you know that this is glass ionomer. So if I ask you like, what powder is, glass ionomer and list different powders, you see the one that has glass in it and fluoride, right? Some kind of, so you'll know it. You'll be able to recognize it. Okay. Again, the great thing about the glass ionomer in general is that it bonds chemically to the tooth. It's not mechanically. Again, chemical bond is something that we want, and actually can absorb and release fluoride, which is a great thing, right? We know fluoride is really good for our teeth. It helps strengthen them. Having a material that can absorb fluoride when we, get fluoride with our mouth rinses or toothpaste and then release it back is a great thing to have, right? So that's why, again, we have filling materials sometimes and cements and sealants that are glass ionomer. So it comes in different forms. You can have them as capsules like the ones that we have here. It can be a powder and liquid. And again, we're going to mix a lot of types of glass ionomer. Keetac is one of the ones that are used a lot nowadays. Fuji, Shufo. There's, again, a lot of different types. This is Keetac here, the first one that you'll see mixed a lot in dental offices. But again, all of these other different ones you can always also see out there. Now, because glass ionomer is really great, we want to make it even better by making it light cured, right? We can cure it by light. So we made the new type of glass ionomer types that is resin modified. And remember, anything that has resin in it is similar to composites. So technically we can cure it with curing lights. And again, this makes it even more easier to work with. So we can mix it, put it on the tooth, and then just cure it whenever we want or we're ready to get it cured. So it is mainly for crowns and bridges. So it is similar to GIC. And GIC goes for what? Glass ionomer cement, right? So see, this is RMGIC, resin modified glass ionomer. And GIC is glass ionomer. So it is similar to glass ionomer, but we added what? Resin, exactly. Properties, it can be light cured, it can be chemical cured by itself, or it can be both. It releases fluoride, exactly. It has some expansion, so when you cure it, it might expand a little bit, but again, this is something minimal. And the way that it comes in, it can be in powder, liquid capsules, or cartridges where we just mix it right away with like a syringe, and you can use it. So glass ionomer is GIC. So some example is Reliax, which again you will see a lot in offices. There are different types of Reliax, as you can see. We have like a syringe that you can just use right away, or the clicker, or this hand mix one as well. Let's see how much more we have. A few more, and then we're going to watch some videos about these. Okay, so zinc oxide eugenol, which we talked about, ZOE, right? So now we have ZOE, ZNP, right? GIC, and then what? Resin modified, GIC, all of these, right? Okay. So zinc oxide, we also already talked about again when we talked about temporary restoration. So it can be a base, usually weak base. It can be temporary restoration. It can be a temporary cement, right? And is rarely used as permanent cement. Um, just unlike the other ones, which were mainly permanent cements that we talked about. The powder is zinc oxide, and then the liquid is eugenol. Some of them are non-eugenol ones. It's a low strength. We do not want to use under composites because it can interfere with the bonding process of the composites. So if we know that we're doing a composite filling, we don't want to use zinc oxide, which can be like IRM, the intermediate restorative material, and underneath it, because again, it can interfere with the bonding process. Eugenol is sedative, right? We know that's one of the good thing about zinc oxide eugenol is that it has the eugenol in it, and the eugenol is sedative, so it can kind of calm down the tooth a little bit, especially when we use it as like an intermediate restorative material in between treatments to get so the patient would not feel that pain in their teeth. And then again, it can be in a powder, liquid, paste and paste, or capsules. And some examples are IRM, which is the intermediate restorative material, or just regular zinc oxide eugenol that is used as a temporary cement. Any questions, guys? We're going a little bit quick, but again, I mean, once we start mixing these, it will make a lot of more sense. But we have to get to know all of them, the different cements products, what are the different properties of them, the powder and liquid, and any other information that we talked about here. So these are the capsules, and again, we'll mix all of this in the lab. So this is what we talked about a little bit when we talked about the resin modified glass ionomer. So again, any kind of resin, we know that we added resin to it. Some cements that we added resin to it to make it easier to manipulate, and we can manipulate and we can cure it. So it can be used for orthodontic brackets. It can be used for indirect restoration or temporary cements sometimes. So it is similar to composites, as we said. Composites, because it's resin, it's insoluble. We have a lot of shades. So again, and this is the aesthetic part, because we can sometimes use it like under veneers specifically, because veneers are really thin and they can show through whatever underneath them. So we can at least have different shades to choose from when we are trying to choose a cement to use. So we use the resin cements, and they can be light cured, dual cure, or chemically cure. So that's another good thing about them. Compomers, this is kind of the newer types, or like it came a little bit later. That's the kind of most newer cements that came up. Technically, it's similar in a way to resin cement, or they call it like a subset of the resin cement. Mainly, it has, again, like a resin and glass ionomer, just like the resin modified glass ionomer, but it's a little bit different components or different mixture. It releases fluoride. It can be self-cured. So it's technically the same formation that we talked about resin-modified glass ionomer in the first place. But these are not much widely used because people a lot of time use resin-modified instead of the compomer types. Any questions? No, all good. Let's watch some videos here. Let me stop the recording.